The biggest advantage robots have is their interconnection in a cloud, making it very simple to learn and teach new tasks. Once we are able to instantaneously receive required information or use external processing power, we may be able to keep up with them. Brain-computer interface, or BCI, will increase communication and interconnectedness between individuals all around the world. We have morphed our lives to incorporate phones, while BCI will be simpler and more natural to use. With this, we will not be looking away from our surroundings to check a screen, which will make the communication more seamless because everything is in the brain. The downside, though, is that technology tends to distance people from their environment and create a less interactive community. Improving mental performance and capacities of individuals would affect even those individuals who abstain from wearing it. This is because individuals wearing it will be functioning on a different level, creating an unhealthy split in society. This would inevitably result in a greater socio-economic class distinction, as those without enhanced abilities would experience greater difficulty finding work. The wealthy would therefore gain considerably more power as their intellectual abilities grow, which allow them to control political, international, and other important affairs. Technically speaking, though, it is not fair that some people win the genetic lottery and are smarter than others. So giving the option for everyone to acquire a BCI would even out this playing field and create a more superior population that can look towards the stars to pursue more challenging problems. Another concern is the possibility for breaches in privacy and security. Human enhancement through the internet could provide digital viruses access to the embedded hardware. Whether this issue is realizable is yet to be known. However, it could theoretically allow governments or external parties to hack an individual's BCI and allow them to track your Google searches or the type of information you are absorbing. While this can prevent deadly attacks from anyone who desires to design and deploy explosive devices, this could considerably reduce the autonomy of the user. Meanwhile, it could also be re-engineered, such as letting a hacker delivering a deadly shock to the user. If a hacker can commit attempted murder by hijacking a pacemaker, think of the damage that could be done with an invasive BCI. Furthermore, who is responsible for the output of the BCI? If a BCI device detects a user's thought and executes a harmful action based on such a thought, even though the user would not have acted in such a manner alone, is the user fully responsible? To decrease the effects of this inevitable future, one possible recommendation would be to enforce restrictions or limitations on a technology's functionality or features before further development occurs. By limiting the design to a basic level of functionality, it could prevent or reduce its misuse or corruption. For example, the BCI device could have an option of being turned on or off on demand. This will allow the user to make decisions without the influence of the BCI device, thus respecting user autonomy and privacy. Another possibility would be to limit the access to this technology. If only a selected group of qualified individuals reap the benefits with the goal of benefiting the entire race, the potential large disparity between classes could be reduced. Finally, security and access control measures could be implemented by a presumably unbiased third party that is not the government. Extensive encryption and protection can make it more difficult to exploit, and by that we mean the device would stop working if an attempted hack occurs. This provides users with increased autonomy and privacy. The security should be implemented within both hardware and software domains, and it should also be designed to meet a set of safety protocols with several fail-safe mechanisms to protect our sensitive organ, which is the brain.